Hi, my name's Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to be talking about one-step conversions. So we got 5 problems that we're going to talk about to help you guide your way into doing those one-step conversions. Okay. Now, in class, we took notes on how to do things step by step. So if you want to take a screenshot of this just so that you have it, maybe zoom in if you need to on the directions of how to do the things that we're doing. We also took notes on these conversion factors. These conversion factors are things that you're going to have to memorize, okay? So make sure you start working on the memorization of the conversion factors so that you can learn how to do one-step conversions, okay? So let's jump right into it. Our first problem, we're going to convert 0.85 kilometers into meters, okay? And according to the directions, the first thing that we're going to do is we're going to draw our train tracks. So a train track is just a horizontal line with a vertical line to break things up, and you can use as many vertical lines as you need. The next step is to put the given in the upper left-hand corner. So the given in problem 1 is going to be 0.85 kilometers. So that's what goes in the upper left-hand box. Okay. Step 3 says on the bottom half of the first track, bring down the units. So I have kilometers up here, so I'm going to bring down the units. And we do this so that they cancel out, because when you have a unit on the top and it's the same unit on the bottom, they're going to cancel out. And I want the kilometers to cancel out because I want to convert them into meters. And that's what I'm going to put on the top half of that first track. And that is going to be step 4, is to put the unit that you're trying to convert to, which is meters, on the top half of the first track. Now, the next step is we got to put a conversion factor between kilometers and meters. And that's where we're going to use this sheet, okay, to determine that. We're going to find that line that has kilometers. 1 kilometer is equal to 1,000 meters. So we got to match those numbers up, okay? 1 goes with the kilometer. There's 1 kilometer for every 1,000 meters. And we're going to multiply on the top, and we're going to divide on the bottom. So I would take 0.85 times 1,000 divided by 1 to get your answer. And if you do that work, okay, you're going to find out that the answer is going to be 850 meters. That's going to be the answer to problem number 1. Okay, now let's try the same process, and the problems will get a little bit more challenging as they move on. So question number 2 right here is the given is going to be 1,800 liters. So I'm going to put that as my given in the upper left-hand corner. I want to make sure that you know that this is a comma, so let's make that a comma a little bit better. And remember, in this next step, whatever unit is up here, we're going to bring down here in order for them to cancel out. So we want the liters to go away, so something on the top, something on the bottom, and it's going to go away. Okay, now what do we want to convert to? We want to convert these liters into kiloliters. So I'm going to put kiloliters on the top. And I need this conversion between kiloliters and liters. And it's the same line that we used before between the kilometers and the meter. 1 kilometer is equal to 1,000 meters. Well, 1 kiloliter is 1,000 liters. So this conversion factor is exactly the same as this conversion factor, because both of them are going to go from kilo to their base unit or their base unit. But if you look at this problem, you're going to see that the kilo is now on the top, okay? So you got to make sure you match up the number appropriately. There's 1 kilometer for 1,000 meters, the same way that there's 1 kiloliter for 1,000 liters, okay? So you got to be careful. One of the things that people do is they end up flip-flopping these and they get the wrong answer, okay? So just remember, it takes a lot of the smaller units to make up one of the bigger unit. Lots of the smaller units to make up one of the bigger unit, okay? So remember, we multiply on the top and we divide on the bottom. So this time it's going to be 1,800 times 1 divided by 1,000. And when you do that work, you're going to end up getting 1.8 liters, okay? Now let's work on to the third problem where we have decigrams. So problem number 3, okay, says 45 decigrams, and I'm going to put that in my given, and I'm going to start working the problem. Whatever unit is right here, I'm going to bring it down. Whatever unit I want to convert to is going to go on the top, and I'm going to have to find that conversion factor once again between decigrams and grams, which is here towards the bottom. 10 decigrams is equal to 1 gram. So 10 decigrams is equal to 1 gram. Lots of the smaller units to make up one of the larger units. And 45 times 1 divided by 10 is going to be 4.5 grams as an answer. Okay. Now, when we get to 4 and 5, we're going to have to start using exponential notation in our calculators, which can be a little challenging for students. So let me come over here, grab my calculator. So I am ready to go for this type of problem. I'll show you how to punch everything in the calculator when we get the problem set up. So question number 4 says we have 0.59, and this is capital M, so that's megagrams, is equal to how many grams? So 0.59 megagrams, and I need to convert the megagrams into grams. So I'm going to convert the megagrams into grams, and I need this conversion factor between megagrams and grams. And as you can see, megagrams here at the top, 1 megagram is equal to 1 times 10 to the 6 grams. Okay, so 1 megagram is equal to 1 times 10 to the 6 grams. Now, we got to be able to punch this into our calculator, which a lot of students can have a little bit of difficulty with when they're first learning this. So I got my calculator here. I'm going to put my given in of 0.59. So get close, 0.59. And then what I need to do is I need to multiply by 1 times 10 to the 6. Okay. And so I'm going to do that. Okay. So I'm going to do 1. And I'm going to hit the second button and the comma, and you'll see that an E pops up. And what that E means is that we have exponential notation. It means 1 times 10 to the what? Well, we want 1 times 10 to the 6. So that's what I'm going to do. Okay, and then you can hit divide 1 if you want to, but anything divided by 1 is the same thing. So these 1s, I'm not sure how much they matter. And I'm going to hit enter. Okay, and you're going to find your answer to be 591,000 as an answer. So 591,000 grams is the same thing as 0.59 megagrams. And when we get to our last problem, we not only have exponential notation here, but we're going to have exponential notation in our conversion factor. So this is kind of like the hardest of the 5 problems. So let's go ahead and set it up. We got 1.78 times 10 to the 7th meters as our given. And we need to convert those meters into gigameters. So meters to gigameters. So we're going to look at our conversion factor here. And it says 1 gigameter is equal to 1 times 10 to the 9th power in meters. So 1 gigameter is equal to 1 times 10 to the 9th power as far as meters are concerned. So let's go ahead and put this in our calculator. So I'm going to do 1.78, and then I'm going to go exponential notation. So it's second comma to get that E in there. And it's 1 times 78 times 10 to the 7th power. And I'm going to divide that by 1 times 10 to the 9th power. Okay, so that's how everything should be inputted. If you want to hit the times 1, you can, but times 1 is just going to give you the same number. I get a number of 0.0178 as my final answer. 0.0178, and that's going to be gigameters because the meters have canceled out. Okay, so that's how you do one step